Good Saturday evening, everybody. It's David Schlotthauer here in the Weather Center with an update on your weather forecast. And tonight, it'd be a little different because we're going to have some fun. We're going to have a lot of fun tonight. But we're first going to go through the forecast really quick because some of you in the voting wanted me to go over the models. What are the weather models? Why are they important and everything? And then probably our last 15 or 20 minutes, we're going to have a lot of fun here in the live stream. So if you have not invited your friends and family to tonight's Saturday Night Live weather talk show with David Schlotthauer, please do so right now. We're going to have a lot of fun. Probably the funnest stream that we've had in a while. Instead of just focusing on like extreme weather, we're actually going to have a lot of flexibility tonight, including your best weather show ever. Okay, so this is what we're looking at right now. This is and if I sound a little congested, allergies or whatnot, congested nose recently became an issue literally within the last 15 or 20 minutes. I had to start acting up, so I did take some allergy medicine. So hopefully that kicks in a little bit here and my allergies will be a lot better. So now looking at that imagery, yet again, we are looking at some really active weather across the west. Well, it's a lot better back across the midsection and the eastern half of the United States, and got some good news. You'll be warming up. But we have this trough that is over California, over Nevada. This is bringing there have been numerous reports of lightning and thunder already in the central and southern half of California, part of this upper level disturbance. There have been even a few reports of some hailstones actually with some of these storms. So it's been a very active one. But if you're up here across northern tier of California, it's been a really, really, really windy morning and afternoon part of that pressure gradient that is getting tighter and tighter, and that's going to continue to get these winds to pick up. So looking at that area, again, that's our weather system. And this is going to be the same weather system that is going to be moving into the high plains by the end of, pretty much a week from today. We're going to see some active weather shape up over the high plains, the deep south. This will be our next weather system that we'll have to monitor for the potential for a notable severe weather event, especially down here in Dixie Alley. And then, of course, for the north, we're going to need to keep an eye on temperatures for the potential for snow showers over the Great Lakes and also for the northern plains of the United States. All right, so so this is what it's looking like right now. And it's always nice to see a change in the weather pattern that is coming for much of next week. So now let's take a look at our European model. We're going to just look at two models in tonight. And before we actually get to the forecast, I want to briefly describe to you all what are weather models, why are they important for everyday life. You'll hear that term in other live streamers. Oh, we're looking at weather models. We're looking at so-and-so. So what are weather models? Basically what weather models are supercomputers, all right? So it's basically a supercomputer and it simulates. So basically it takes everything into account. So let me go to windy.com here. And so, because this is going to actually help us out a lot on the layers that the models actually use. So if we go here, we can see there are different layers. So we have our wind maps, we have our temperature maps, we have all of these different layers, okay? And you can think of this. All right. Oh my gosh. Someone is spamming. Literally, get out of the channel if you're going to be spamming like that. Thank you. He's hidden. No moderators tonight, so I'm hoping we get a moderator here to help moderate the stream if possible. Thank you. So there are different layers here that models use, and basically these give us different snapshots of different layers of the atmosphere. But more importantly, the initialization takes place. So there is 4 times a day that these models take a picture of the atmosphere. Well, not literally take a picture, but it's used by satellite data. And all that satellite data, surface observations, weather balloons. I don't really use the term weather balloons a lot in my videos, or otherwise my videos just end up being too detailed and too festered with that. So I try to simplify it a little bit more. But yes, there are weather balloons, surface observations from weather stations, from National Weather Service stations, as well as automated weather observation systems that feed this data into the models and basically give us a current observation picture on what the weather is doing right now across the United States. Okay, but it's not just that. All that data is then fed into the supercomputers where it generates basically a forecast, a simulation of the atmosphere, because the atmosphere is really fluid. Hopefully I'm doing really good at explaining things here. But the atmosphere is really fluid, okay, in fluid form, and it is complicated to basically forecast, not even in the short term, but it's more in the long term, because there are pieces of the puzzle that make things complicated. And supercomputers try to resolve those as good as they can. That's the whole goal with weather models, is trying to be as accurate as possible, but sometimes it's very complex. So let me show you something here. Let's go to our weather model form. Weather model formulas. All right. So let's do this. No, that's not what I'm looking for. Basically, this is it. Well, numerical weather prediction. So if we actually click on that, that's what this actually is. Numerical, or NWP, are mathematical models. Think of an image. Okay, think of this image on your screen right now. What we're looking at right now is ones and zeros. It's numerical form. So basically it's extrapolating it for us to read it more simply. So as we go further down here, let me find the concept here. It's probably not even down here. Hey, that is Rita, Hurricane Rita, with numerical form, ensembles and stuff. So let's see here. Wow, man, it's not on here. I thought they would have it here. Weather formula. This is more basic, but I wanted to maybe an image. All right, so this is it right here. So we're going to actually open this in a new tab. Yeah, try solving that. Try solving that. I can't even do this. Okay. I know a lot about weather, and I can't even do this. But you have your weather equations for zonal wind. You have your equations for meridional wind. Your temperature equations, your precipitation or precipitable water equations, pressure thickness equations. You have all these different equations. So basically, every layer that you look at, so like let's just do this. This is your precipitation layer. This is your lightning map layer. This is your dew point layer. This is your precipitable water layer. This is your visibility layer. This is your PWAT anomaly layer. Your precipitation layer, how much rain it has fallen. Your pressure anomaly layer, your wind, your temperature anomaly, so and so forth. The list goes on and on and on. And each thing, okay, this is very complex. Think about it this way. Each thing it has its own calculation. All right. It's basically supercomputers are super calculators of the atmosphere. It's calculations, primitive or equations of the atmosphere. But not only that, have you ever wondered this? Equations are, oh my gosh, please stop the spamming. Oh my gosh. Good job, or goodbye, add-on. All right, so sorry if it just popping up all over chat there. And so basically, when you have your equations of the atmosphere, there's grid points or grid spacing. So if you wonder why things don't look high resolution, and let's go right back to this. This is basically your GFS model, all right? And an image is an image, but we want a fine-tuned forecast, right? This is what a global model looks like as far as our wind forecast, right? Things are not really resolved very well here, even with the complex terrain, right? Things are just kind of mushy-mashy, really blurry, just not very high resolution. But when we go to our Euro, things are a little bit more high resolution, right? Just a little bit more. But then, because the grid spacing is a lot more tighter, right? It's, I think, per 4 or 5 kilometers grid spacing. Actually, no, it's probably a lot more than that. And then our high-res models is 3 kilometer grid spacing resolution. Let's go to that. And look at how much high definition this actually is. All right, so sorry, man. People, we'll get to that in the chat in a second. But yeah, this is much more high res, clearly more high res than that. So you can see the difference. That's why we use high res models in short range forecasting, because this is a lot better image at actually it takes terrain into account. And you can see just the little ripples here. This is all higher elevations versus the Euro does a little bit better job. The GFS here, this is a 22 kilometer resolution model, and this is a 3 kilometer resolution. The NAM is a 5 kilometer resolution on this program that I use. So you can see the difference between a very blurry, un-high resolution image versus a much more complex high resolution image. And it's more complex equations. It really is. All right, I am sick and tired of all the spamming that is going on in this live stream, and there is no moderators to help at all. So I'm hoping moderators will be able to help with that. This is disappointing because this is not having a fun time when we have spammers in the live stream. I'm the one that's hiding them. So you can thank me for right now, but I'm really hoping we will get some help in the live stream here, because I want to move forward with this without getting distracted with stupid chats in the live stream. It looks like our model just went out, so we don't have that out. But also we can see our temperatures too at a much more high resolution. All right. Yeah, at this time I'm gonna just add any more any moderator that I can have temporarily just for this live stream. George, I am going to add you as a standard moderator just for this stream. So there we go. So that should help a lot now that we have a moderator in the live stream. So yeah, this is why we use high resolution models at closer range. So now let's put this to the test, right? Let's look at our models and let's see what is coming for next week. Nothing too extreme now. We were thinking that there could be a good, decent snowstorm. That has really backed off, and now it looks more of a rain event for the deep south. So as we go forward here, you can see the only snow you find is in New Mexico, and then it just doesn't look to be a snowstorm like what models thought just a couple of days ago. You never know these kind of things, right? Models could do some crazy stuff, especially this time of the year. The jet stream is beginning to weaken a little bit, and you get a lot of rainfall that starts showing up in the further deep south because temperatures are warming up. And you do get some snow that does happen occasionally if these storms are cold enough. So that's the system that's going to be moving into the high plains by the end of next week. But then look what we got going on over here across California. Rain, snow, colder temperatures. Hooray! It's welcoming news. It really is. After being dry for so long, other than our little pesky system that's overhead, might break the drought or dry streak, especially for Southern California that hasn't had rain at all this season so far. It's welcoming to get rain there. Now that goes into the Midwest. That system that we have now goes into the northern plains, the Midwest, and the upper Midwest by Sunday, the 2nd of February. And this is in a fantasy land, so this is more uncertain than anything. Because if we look at our previous run, boop, very different. Look at our latest run, boop, different, right? That's our 12Z run. And then going forward, just not a whole lot of active weather out here now for the Midwest or for the eastern half of the nation. More active weather, though, for the California region, for Nevada. Look at these temperatures. Going to be much colder, and I'll show you the temperature anomaly here in a little bit. Really, really impressive Arctic high that builds in over the northern plains and the Pacific Northwest. And then we will see. This is beyond the 10-day forecast. Maybe another winter storm. Who knows? Who knows what at this time? Models don't know what to put in. Great example, 0Z run from last night. Nothing. February 5th and February 5th tonight with a snowstorm and ice storm for the northern plains that moves through into the Great Lakes, into the northeast. And then look at this. More big storms for California. Really welcoming sight here. More significant snow for the higher elevations and more needed rainfall for the lower elevations. All right. And then that moves into the plains. And that brings more snow for Iowa, for maybe Wisconsin, for the Great Lakes. But yeah, 360 hours out. Yeah, that's fantasy land. There's chances of this happening 1% or less. 1%. We look at signals before we look at actual storm systems. But yeah, the pattern could remain pretty active from about over here, at least, from about over here into the west and the Pacific Northwest, as we get more zonal flow ripping across the area, maybe even southwesterly flow over the plains that brings in warmer air out of the south, brings cooler in out of the north. And yeah, if things merge correctly or collide, you get some big, interesting weather producers here in the plains. Now, you guys are going to probably laugh at this, and you guys are probably making comments about California. Like, did you see the Euro, David, that there's snow down to sea level? Yeah. You guys can laugh at me all you want. This is not happening. This is not going to happen. This is one stupid run of the Euro showing snow down to sea level, like down to about 5 or 10 feet to be specific. Actually, no, there is snow down to sea level because the delta is below sea level, actually minus 5 or 10 feet below sea level in portions here. Okay. Yeah, there's snow down to that level. And look how cold this air mass is. Really, really cold as well. Our thicknesses here, really, really tightly bundled. That means there's a lot of cold air to the north. And yeah, there's snow down to the surface. So I don't think that's going to happen at all. Okay. I just don't see it happening. Because if it does happen, yeah, it'd be historic. It would be California's turn to see historic snowfall totals down to sea level. That would be about 15 inches of snow. Yeah, it's not happening, all right? Forget about it. Just don't plan on it. But if it does, yeah, it's going to make a lot of headlines, okay? So that's that. Now, some of you are probably talking about South Carolina and the Carolinas. Yes, so you'll be in and out of rainfall. No snowfall in the forecast at all. It's just going to be rain, 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 and rain. Just no snow, no ice, no nothing. The pattern that we're entering does not favor that. Ridge across the east, trough in the west, so you can kind of think about this, and we get flow. This is over exaggerated. It's not going to be like this, but you can kind of get the idea. Ridge here, trough here. Southwesterly flow in the Midwest, or even zonal at times. Cold air stays north, warm air moves north with that. So yeah, areas that were once 5 or 10 degrees above zero might be in the 50s and 60s by early part of February. Yeah, spring is coming, folks. It's coming. All right, what does a GFS model show? Well, pretty much similar like what the European model is showing. Not much of a big winter storm at all for the Midwest. Actually, that's why I did not make a video today. Instead, I made a live stream, like Saturday Night Live here, because there's just not a whole lot to really digest. But I do look into uploading every day, and I'll continue doing that. I'll just have to figure out how to do that. Now, if I do have morning videos out, that's just because of my work schedule. So just my work schedule right now is very, very complicated, and there are times where I can't do the afternoon. So that afternoon video turns into a morning upload instead for the rest of the day. So don't be surprised if you see a morning video from time to time this week. All right. So there's that snowstorm by the end of next week for the Intermountain West, moves into the plains, and the GFS being a little bit more snow friendly for the Ozarks, but otherwise just rain for the deep south and for the southeast. Here comes another sniffle, another sneeze. Maybe it's just the weather for us. And then more colder temperatures, more snow for the west. Yeah, for the higher elevations, that is. And then more, believe it or not. So there is consensus here from the Euro and the GFS that the pattern is changing. Colder out west, snow for the mountains, rain for the valleys, and warmer for the deep south. Yeah, you're going to like these temperature anomalies. So how much snowfall over the next 2 weeks? All right. Warning, folks, this is fantasy land. This is over-exaggerated, all right, because we are looking out to 2 weeks. There's not really a particular snowstorm that we're focusing on. We're just focusing on the overall signals in the pattern. But up here to the north across Quebec and Ontario, Canada, could get a few feet of snowfall over the course of 2 weeks. Over across Manitoba, Saskatchewan, Alberta, and British Columbia, about a couple of feet of snow too. Look at the Sierras, though. The Sierras could get extreme amounts of snowfall accumulation here. Look at this. Some higher elevations could get over 100 plus inches of snow. In other words, you could be looking at 3 to 8 feet of snowfall over the next couple of weeks. So good snow coming for the West. The European model, if we go to that model, that is also very consistently high as well. This is pretty aggressive, actually. Similar amounts over the course of 2 weeks, showing a lot of snow. Now, please ignore all of this in the valley because that's that winter storm that we showed. Yeah, it's not going to snow down to the valley floor. I can bet 100 or 99.9% that there will not be snow down to 0 feet or down to sea level. Now, there might be snow up here near Redding, because in Redding, it gets cold enough at times where you can get some wet snow there. So don't be surprised by that. But yeah, over here, just fantasy land. The Euro is just going crazy, all right? But it is a possibility. Anything is a possibility, and that's why we use these models. That's why this is possible, based on those calculations, based on the primitive equations of the atmosphere. But yeah, get ready. A lot of people out west have been wanting snow and rain. Yeah, you're getting it for for the end of next week, very end of next week, and end of February. Looks really different. Looks really cold, stormy, and wet and snowy, pretty much at this point. So now, temperature anomalies. Yeah, goodbye. You all can say goodbye to the cold Arctic air. Yeah, look at this. It's going to be warm, going to be above average by the middle of next week, and it's only going to get warmer. Yeah, you get one more last taste of winter for the Northeast, and then good old bye. Goodbye. Goodbye, Arctic air. It's going to be warm. It's going to be much warmer across the eastern or east of the Rockies, very similar to our December pattern, where it was like this. There literally was above average for the east, below average temperatures for the west, and I'm talking really cold temperatures are coming out across the west. This would be record-breaking temperatures for California, for Nevada, for Oregon, and Washington. And the cold air tries to extend its legs into the Midwest, but it really doesn't get very far. It really doesn't. It stays above average here for the Southeast, for the Midwest, and even for the Great Lakes. Whereas the West, welcome Canadian Arctic air. It's our turn to get it. And I'll tell you, some of these temperatures here, if this pans out right about in here, these temperatures are about 20 degrees below normal. And there's one period, right here. These temperatures here are about 27 degrees below average. Your daytime high is in the mid-30s. That's where your snow is coming from. If we actually look at that, see? That is the reason why you get snow, because it's going to be cold enough overnight for that. But I'm just telling you, it's not going to get that cold. I just don't think it will. Because if it does, I will promise you, it's going to be making a whole lot of headlines. That is a guarantee. So now, why is this pattern going to be a thing? Why are we seeing this change shaping up? Well, as you all are too familiar with, ridge out west. This is a big ridge of high pressure, an omega block, more troughing out across the east, right? That's been the whole pattern for a while now, where we have these troughs building across the northeastern U.S., right? That's a big one right there. Nice good old ridge right here. Another trough here, and then another trough. But what this is going to do is it's going to weaken this ridge over the west, and what you're going to end up seeing is things are going to merge quite significantly. So this trough that is across Alaska right here is actually going to drop down into California. You can see that here as we move forward. There it goes. It goes right on down to California. If that actually happens, that gets us into a much colder pattern because, well, guess where our flow is coming from? It's coming from Canada up here, northern Canada, then it comes all the way down, okay, and then it comes all the way into Southern California. If you think about the cold Arctic events across the west, well, that's where it comes from because you have a very amplified wave pattern here. You get a trough that is very amplified across the west, and that brings in all the colder temperatures from higher latitudes. So instead of this trough right here being over here, right, bringing in northwesterly flow, it's going to get northerly flow over our area. And it just continues. Look how deep this is. This is really, really deep. That's a 528 decameter low. And then it just continues. Look how deep. This is quite incredible to see. Lots of Alaskan ridging here. Lots of troughing over the Pacific Northwest and California. And a ridge over here across the east. Another ridge or trough here. So it really makes sense. Ridge here, trough here, ridge here, trough here. So it's kind of a pattern, just like a very amplified wave pattern. And you can see, look how amplified that is. That's a 580 decameter ridge. That is very, very amplified. Very amplified. So let's go back and look at the GFS model. What does that show? Very similar. Okay, so this trough seems to happen on both of the models in today's runs. So if we go and look at the same time frame, except the Euro is a little late at it. 216 hours. This is where it's at. The GFS, much further south in the same time frame. That moves out. And then look at what we got. Very deep low off of California. And it just kind of stays that way. Really amplified. In fact, let's go to the North Pacific because I want to show you this. Yeah, this is totally fantasy land. This is super fantasy land. Who could ever imagine a ridge being that big? I mean, seriously, it's hard to believe that something that big will actually exist on the models. Is if that actually happens, boy, it's going to be really warm relative to average over Alaska. Because Alaska right now is going to see below average temperatures. I mean, they're going to see some all-time record low temperatures there during the day and night. With temperatures in those areas, that could be as cold as negative 50, negative 60 degrees below zero. Very, very cold, dangerously cold up there. And then once that pattern changes, again, we have this high ridge of high pressure, or this trough, then it becomes a ridge. And this really causes the pattern to change across the west. It really does. Very standing wave, very extreme too. I mean, your subtropical jet does this, and your polar jet does this. Very La Nina-ish, I would say, because you have a ridge here instead of a trough. And then that just allows storms to come on in. We'll have to see, though, if there's any moisture that taps in to those storms that brings us any meaningful precipitation. Doesn't look like a whole lot of PWatt values don't get involved very much. So the good news is, fortunately, well, good or bad news, however you want to think of it, the bad news is it's not going to be a wet storm. You know, that could really help California's drought in Southern California. But the good news is there's not going to be a whole lot of flooding with these storms that move through because cold air holds lesser moisture. Lesser moisture means lesser chances or any opportunity of any meaningful precipitation. But yeah, this is some cold, dry air right in here, coming off of the Canadian Prairie, which, by the way, when you hear me say Canadian Prairie, that's up over here. That's the mountains, the Prairie of the mountains, that is, in British Columbia. And the only way California gets such cold Arctic temperatures, including Nevada and even Oregon and Washington, is when you get these Arctic air masses that move offshore. Okay, because if you get these Arctic air masses that originate from Alaska, it's going to bring cooler air, but it gets modified because of the sea surface temperatures. Got to understand, water doesn't cool off as fast as land does. So if you imagine, you get these Arctic air masses, yeah, there's a lot of water distance between California, Oregon, and Alaska, the Aleutian Islands. So that's why there is such thing as a modified Arctic air mass versus one that's not so much. Like this one right here in California, it gets really cold at night because, well, if we look at our flow one last time, our 500 millibar flow, that's northeasterly. That's directly from land areas, and it comes offshore. So, you know, as long as you don't modify that air mass very much, things get really cold here in California. It works out that way. But yeah, fortunately for a lot of people that don't like the cold weather, you're going to like the end of next week. And with that being said, let's actually take a look here at the Climate Prediction Center forecast. So let's go to that. And this is what it's showing. So yeah, warming up. Who likes warm weather? Yeah, that's going to be the last day of January into February. Really ending January warm, finally. And beginning late January, early February on the cold side for California. And this continues through the 8 to 14 day forecast, showing below average temperatures across much of the northern plains, the northwest, and the Intermountain West of California, versus, yeah, areas over here are going to have a battle zone between really warm or really cold, but I think it's going to be really warm, warmer than average, that is, from about roughly, I would say, right about in here, I think, is where all the warm weather is going to be in place through the first full week of February. So don't expect February to be cold at all for the Great Lakes, for the Deep South, for the Eastern Seaboard, or for the Northeast. Pattern is going to change. It really is. And hey, I'm ready for a pattern change. I think all of you are too. Yeah, well, unless you're over here, it's going to still be cold. But yeah, areas like Oregon, Washington, and California could really use that pattern change. Precipitation-wise, definitely on the wet side for much of the U.S. The difference here is with above average temperature chances means less opportunity for snowstorms. 8 to 14 day forecast, pretty much the same thing. So it's not really drying out here for the Midwest or for the Deep South, but it's going to be warmer. So it's going to be a warmer storms, not cold storms. And then it's colder and wet here for California for the next couple of weeks. Yeah, that makes sense. All right, let's see what I was going to use. Oh, yeah, I wanted to show you the actual air temperature here because this is pretty impressive. Remember how cold it is going to be briefly? One last little bit of Arctic temperatures, or kind of a modified version of that. Let me go back to Weather Bell. Watch this. Let's watch and let's go all the way into the middle of, or the end of next week. So this is, or yeah, the end of next week into the earlier following week. In that 50s I'm looking at, in that 50s and 60s, it looks like it, huh? Look at this, Southern Illinois, low 60s perhaps. Yeah, we've got 70s and 80s in Louisiana. Yeah, 80s. You were just at the single digits overnight. Yeah, going to be 70s and 80s. Believe it or not, yeah, close to 80 right there in New Orleans, Louisiana. And it's going to come with a great cost, more humidity. So it's going to be tropical-like, where Louisiana should be tropical-like. And it really gets warm. Look at this. Temperatures in the 90s in southern Texas. Man, dude, I'm telling you. I am telling you right now. Hello? We were just in the 20s in single digits down there. Not anymore. Not anymore. It's on this model, be really warm, even into northern Illinois. Way, way warmer. Yeah. It's going to be lovely. It's going to be nice to walk your dog out there finally, right? Unless you're up here in the Dakotas. But that's where the cold air can stay. It belongs in Canada. It belongs in Montana. That's where it needs to stay. It doesn't need to be down here in the Deep South. That's not where it belongs. That, doesn't belong there. '50s is a dream here in the Midwest. Yeah, it is. And when we look at those temperature anomalies, yeah, look at these. That is 40 degrees above normal. 40 degrees above normal for these locations. So, yeah, that is unseen with those temperatures. Rio Rancho, Mexico. So the snowfall forecast, again, it's not really defined. I'm not giving a definitive snowfall forecast. Well, actually, with our first system that rolls through, that kind of just sits there. Rio Rancho, New Mexico. Let's go to Rio Rancho. So that's kind of northern, central-ish Mexico. So you could see about 2 to 5 inches of snow. All right, 2 to 5 inches of snow with this system that we're getting in California right now. I wanted to show you something too at a closer zoomed-in view. Pretty interesting satellite picture that you don't see very often in California. Yeah, here's that upper level low that is right here, and look at just how it develops. It really develops really quickly. We actually had some pretty strong winds today out of the south. Yeah, not out of the north. Areas up here had north wind. Areas down here where my mouse is, it's probably hard to see. Down here had south wind, north wind here, south wind here. You can follow the cloud motions on why that is. So there's your system right there, and it's just spinning about. And again, there have been some thunderstorms associated with this system. And yeah, even some lenticular clouds forming as well. So yeah, there's rain down here in Southern California, a little bit of moisture not found where I'm at. So the dry streak shall continue. And this is some really, really dry air. Dew points up here, by the way, in Northern California are in the single digits because of that drier air mass that is in place. So you can just see how that kind of progresses. And if we actually look at the actual height map, there it is. Really well done. Models handled this quite well, actually. I did not believe this until it actually developed this morning. I'm like, wow, we're actually going to get a low pressure system. It's incredible to see something like this develop really quickly. In fact, it was clear this morning, and then boom, it got really cloudy. Actually, kind of cloudy, that is. Yeah, pretty cool stuff. Yeah, put out those fires, I do agree. There is orographic lift down here. There is some forcing over the topographical terrain. Yeah, there is. You can definitely see some forcing over the San Gabriel Mountains, helping to bring in moisture. In fact, dew points over here in SoCal are in the 50s. Dew points in the 50s. Just a couple of days ago, they were in the single digits and negative territory. A whole different pattern. In fact, if we go and look at the last couple of days, and this was the pattern. Look at the fires down here blowing up, extreme fire danger, right? Then the wind's the smoke kind of hanging around here. And then look what happens. The wind changes. All of a sudden, we get onshore flow. So the Santa Ana wind events really back off. And now it's all onshore. So a very big change in the weather pattern finally has arrived, and there is rain down here in Southern California. So that is a welcoming sight to see, especially for the higher elevations that are seeing that moisture. Yeah, there it is. So not a whole lot of moisture, not a whole lot of extremely heavy rain, but yeah, there is a little bit of reflectivity returns in some of these areas. You got some heavier rain showers over Thousand Oaks, so that is good. This is not a widespread rain, but yeah, where it falls is where it puts out any remaining smoldering flames or anything with fire lines. And even over here, there was a big fire up here. Some of the rain is going to move into that area in the form of maybe of some snow, and that's going to really help things out a lot. Then specifically over here, we had a lot of thunderstorms earlier in Porterville, in California. It's quite an active weather scene. Not here, but in Southern California. If we go back and look at this, there were thunderstorms that blew up right here. Pretty intense radar returns. No sorts of any rotation with any of these. But yeah, if you got rain, I'm sure you all are like, yes, we got rain for the first time in literally a couple or a few weeks. 3 weeks it's been. And in some areas, unfortunately, like Northern California, we'll probably end out January very dry. So another full week yet of dry weather to come. 4 weeks without rain is very rare. Don't see that very often, but it does happen once in a blue moon. And when it does, you just hope there's no fires, no strong wind events that could start these fires and spread them erratically fast. But yeah, Southern California really loving the cooler temperatures today, more higher humidity. Yeah, it's just as good as it gets. And there's that fire down there, but that should be put out soon, thanks to all that moisture that's moving into the area. And even some blowing dust, too. Will Louisiana get more rainfall? Oh yeah, you're definitely going to get more rainfall over the next 2 weeks. Yep, there's your rainfall forecast. What do you know? Yeah, Louisiana getting a lot more rainfall in the forecast. No problemo on that. In fact, you're going to be well above average as far as rainfall goes in the course of 15 days. This is your 15-day precipitation QPF anomaly. And yeah, much of the Midwest, the Deep South, will have above average rainfall chances, especially down here for the Deep South. So if we go down to the South Central, you're looking at about 3 to 5 inches above normal. 3 to 5 inches above normal in a 15-day period. Okay, now this, of course, changes from run to run, but it is looking pretty good for Louisiana, for Texas, for Arkansas. Good news, hopefully it's not too much rain, because there could be some flooding if you have a little bit of too much, especially down here in Houston, Texas. Yeah, you're looking at about 10 to 12 inches of additional rainfall. Additional, but more rainfall to come, that is, with these systems that develop out of the Intermountain West. They move into the Deep South. Yeah, it's looking pretty wet. Will Illinois get a snowstorm in about, let's see, snowstorm in about, what was the question, 6 to 7 days? Chicago, you're probably in the Chicago area, so it's going back and forth right now. Based on our latest models, it's going to be very hard. It's going to be very hard to find any snow on the Euro. On the GFS, though, it is also looking very little as far as snowfall goes. Probably about 2 to 4 inches at the very most on this. Sorry, my ears got plugged up there. But the GEFS ensemble, let's go to that. Based on the ensemble. Now, if you are a snow lover and you're basing it off of the GEFS, yeah, Chicago could get 3 to 5 inches of snow in the course of the next couple of weeks. This is 2 weeks. 2 weeks. Okay? Mark your calendar through the 10th of February. This is not one individual storm. This is a combination of many different storms. Looking at the European ensemble, it is also quite similar with those snowfall totals, but lesser for Illinois. More snowy, though, overall for the Northeast, for Quebec and Ontario, Canada. And, of course, for the Intermountain West, wow, the European model ensemble is going pretty aggressive for California. Look at that. Maybe a 3 to 5 feet of snowfall in the course of 2 weeks. That's a strong signal from the ensemble, both from the Euro and from the GEFS ensemble, both indicating that. Okay? For the higher elevations, you know, if I would love to live in Lake Tahoe and witness all this. I'm jealous, but it's snowing in California at least, right? So that is that. Yeah. Let's go and look at the rainfall forecast for the European ensemble, for California, for the Intermountain West as well, because I wanted to show you that too. How about that? So over the next couple of weeks, yeah, looking pretty wet for California. Is that above average? It looks like it's below average. Unfortunately, hey, we can take what we can get, though. It is going to trend wetter, though, at least normal, though, towards the first half of February, the first week of February, that is, because of that storm that's going to bring in more meaningful rainfall, but it won't last forever. But this is a trend up from the last run. And then looking at the GEFS ensemble forecast, let's look at that. Yeah, and it's pretty dry. It's looking, it's more of the conservative version. It hasn't been going too crazy on rainfall totals for the West, for at least California or for the Pacific Northwest, versus the European ensemble showing more of that. And look at the GEFS is going pretty aggressive for the Deep South with all that rainfall. And the ensemble for the Deep South, pretty aggressive too. Look at all that rainfall that is expected down there. So that is some good news for those areas. So some of you are probably asking, what are ensembles? Okay, so let's try to draw this up on a whiteboard. Let me know if you could still see my screen. Can you still see this? I don't want it to glitch out. Can you see this, folks? Please say yes in the chat. I can't even see anything. All I can see is white all over my screen on all three screens. I can't even see the chat. Let me know if you can see that. Yes? Okay. Let me make sure it goes white on my end. Right. Come on. Okay, it looks like it... Did it go white? It didn't. Did it go white? Oh, yeah, it did. Okay. All right. So that's good. So I wanted to explain on a whiteboard. That's basically what this is. So I turned my screen into a whiteboard, so you'll just see white. I don't see chat, so I do apologize. I can't see chat because all three of my screens just went completely blank. All right. Let's go and look at this. So I'm going to do that. So right here is our starting point. So this is our initialization, this dot over here. And I'm going to even draw an arrow pointing to that. So this is our initialization on what ensembles are. And you'll hear that term a lot. Okay. So this is the starting point. Okay. Starting or INIT, initialization point. And so would be, let's just do 18Z. 18Z as in Zulu time, or military time, or Greenwich Mean Time, or UTC time. All right. So basically, the European model, we'll use that because it has 51 different versions of its model, okay? So let's just plot different dots here on your screen, okay? 51 different ones, if I counted correctly. Some of them are smeary. Sorry, this is a rough representation. And so, actually, you know what? That's probably not, that's really too tightly clustered. Let me actually, without deleting my arrow, that might delete my arrow, we have a problem. So let's just use a few dots as a scale, a hyperscale that is. So we'll use just a few dots here, and there. All right, and then we will draw our lines, or yeah, that's what we'll do. So our lines go out this, well, actually, that is too fat. Let me make that a little smaller. So there we go. So these red lines are basically individual forecasts, okay? Individual forecasts. And so you'll have something that looks like this. You have something that looks kind of like that. Something that looks like that. All right. So different points of the initialization. So think about the European model in this aspect. It has 51 different members. Each member is its own model. Model 1, Model 2, Model 3, Model 4, Model 5, Model 6, 7, 8, 9, 10, and so on. Okay? And the atmosphere is tweaked just a little bit. Just a little bit. Because if I remember correctly, the atmosphere is always changing. I should remember that, actually. But the run, if I remember correctly, initialize every 2 or 3 minutes. Okay? And in those 2 minutes, the atmosphere has changed just a little bit. Just a little bit. Just an itty-bitty chance, okay? And that little change makes a forecast differently. So you can see here that this would be your ensemble uncertainty right here, right? the changes or the possible outcome scenario, right? The cone of uncertainty. This is kind of using like a hurricane, but think of it like this. The top of this is wetter, so we're forecasting a lot of rain here, right? This is drier, right? Man, I can't even draw very well on a whiteboard, drier. Okay, and so we can look at this and say, all right, most of the models are not showing wet or dry. They're kind of in the middle, right over here. All right, and so us as a forecast, we could use that to determine what is our most likely outcome. So if we use this, and let me see if we can go over to weathermodels.com and I could even show you this. So, all right, I have to sign in. Hold on a second, folks. Guess I was logged out of everything, which is disappointing. So now I am logged in. So let's go over to the Ensemble. Actually, you know what? City charts. That's what we want. And what I'm just going to do here is I'm going to bring up, let's bring up here, Houston, Texas. Let's just bring up Houston, Texas. All right. So Houston, Texas. I think right here. There's Houston, Texas. So we could actually look at our precipitation matrix. So you're going to see charts like this on X, right? And this gives us basically each individual member. All right, so some members are more aggressive than others, right? So I know this is a hard chart to look at. Member 36, Ensemble member 36, wants 9.7 inches of rain over the next 2 weeks. Member 1, which is right here on the chart, wants 12 inches of rainfall for Houston, Texas. All right, those are outliers. Those would be your outlier model members. But you got some outliers on the low end, like 27. 16 is an outlier for its low amount of rainfall that is forecasted. And pretty much over here, Ensemble member 49 is also an outlier. So we can kind of give an accurate representation that while there's going to be a lot of rain that develops here over the next few days, more rain over here, it looks like, giving us that total of X amount of rainfall between 1.8 inches and all the way up to 9.7, which gives us an accurate reading here of about 4 inches on our mean, which is our Ensemble mean, which is what you see here. Okay, so this is basically your Ensemble mean right here. Okay, this is a blend of all 51 different members to make the Ensemble. So for us as forecasters, we use this to tell us, okay, looks like it's going to be really wet. This works for temperatures as well. If we go to our temperature forecast, right over here, you can tell that most of the ensembles calling for wet or warmer weather for the 1st of February and the 2nd, colder weather out west. So this really does help out us as forecasters to determine what signal is coming. Is it going to likely happen versus just one deterministic forecast, right? So that's how ensembles are. Any questions on that at all? Any questions regarding ensemble models? I want to say thank you all for sharing this too with your family and friends. We got 150 people watching with this live Hangout session. I will have to do these at least once a week, probably on Saturdays, since no one's really working on the weekends. So it seems like either Friday night or Saturday night. More likely Saturdays for right now. We will look into doing that. What's up, Home EF? How are you guys doing, by the way? What's up, David Perkins? If you have not subscribed to the channel, folks, please consider doing so. Please consider doing so. Now, just out of curiosity, for you guys that are watching, no, I'm not worried about my view count. I'm not here for the views or for the subscribers. I want to get some feedback from you guys as an audience, all right? Just a simple question. Again, I'm not here for the views or the subs, right? I'm not here for that, right? But I'm really curious. Really quickly, just out of curiosity, and that's part of these Hangout streams. This is kind of weather discussion, a lot of fun that we're doing, right? It is interesting. My videos here have done so well. Remember when we were tracking that winter storm was getting like 40 to 60 to even 134,000 views on my videos, but in the last 2 days, I could barely pick up 15,000 views on my videos. So I'm just wondering why that could be. So if you guys could help me answer that, because I was doing a lot of research last night on basically what are the sudden drops in view counts and stuff. So as an audience from you guys, help me answer that. That way I could better figure out. And even so, I've been on YouTube forever, I still have hard times recognizing what my audience wants to watch, what they don't want to watch, why they don't watch, why they click, why they don't. Too many commercials? There's not too many commercials. That can't be the reason why. Weather has calmed down. Probably Annie is asking. I was burnt out from work and had to rest. Oh, the weather. Yes, weather moderated a bit. That's understandable. Because again, your guys' feedback is important. It is important. I remember I used to do a lot of severe weather live streaming and tornado stuff. Yeah, and that's what I'm really hoping to do this year, is doing a lot of severe weather live streaming. But my work, it's my freaking work. Every time there's an enhanced risk or a moderate risk or a high risk, I work. Lovely. But I'm going to try to do more, try to call out, especially for moderate risk events. Honestly, I think it's because a lot of people think it is. I think it's because a lot of your thumbnails are a bit clickbaity. Yeah, you see, I don't understand how my thumbnails are honestly clickbaity. I mean, if you look across the weather community, they do the exact same thing. They really do. So, hey, find a new job. No, this is my job. This is my job right here. Yeah, that's understandable, Vicky. People love severe weather and winter storms and hurricanes. Yes. Anything that's more significant weather, extreme weather events, makes sense. There was a historic snowstorm down here in the deep south. So that caught a lot of people's attention. Also, the nor'easter that happened prior to that caught a lot of people's attention. And this Arctic air mass that was there at first, it kind of still is. The remnants of what is left is still there. So I can see why that gets people's attention. And you know what? Honestly, in a relative sense, when I think of it myself, the weather it's going to be active, but like nothing historic. So that I can feel that from you guys as an audience. That's why I love talking to you guys and interacting with you guys. All right. Anything else? That's awesome, Magical Simmer, by the way. You do watch them all. But I do apologize if I do clickbait a little bit. I mean, this is my style. This is my style that I have. Everyone has their own style. And do you all remember this? I want to show you all my old thumbnails. So, yeah, remember all these thumbnails, folks? Old thumbnails. This is how it was before I even used Photoshop. Yeah, everything was different. And I've come a long way to now using thumbnails that are like this. I'm trying to use less, well, not really annotations, but I'm trying to use less, what is it? Oh my gosh, I can't even think. Less elements in the thumbnail and just having an arrow and wording pointing to something. Trying to make it a little more simple. And it seems like reds and blues are eye-popping to the audience. So that's what I'm going to continue with. Thank you, Heidi. Yes, Wisconsin will be warmer, Heidi, in February. Especially southern half of Wisconsin, I believe. It's definitely going to be warming up. Actually, it's going to be most of Wisconsin. Thank you so much. I'm glad you like the artwork with the thumbnails. And believe me, you know how long it takes me to make those thumbnails? You know how long it takes me. I want you all to guess. Guess in the chat right now. That's part of our game hangout night with David over here. Guess how long it takes for me to make those thumbnails. Hours? No, it doesn't take me hours. Nope, it doesn't take me 6 hours. 5 minutes? No, it doesn't. Nope, it does not take me 3 months, Diane. What's up, by the way, Diane? Your name is brown now. It's not orange like it used to be. 25 minutes? Oh, you're close. You're close. Annie is the closest. Annie L says 45 minutes. It takes me about 45 minutes to almost an hour. And you guys are like, dude, what? How does that take? That's basic. You have to think on what you're going to draw. Think about where you're going to put the text. Where are you going to put this? Where are you going to put that? It's a lot of comprehension. You have to comprehend on your style. Where are you going to put this? Where are you going to put that? Your arrow pointing to here and everything. It does take time. And adding the shade effects. If you notice, there's been some shadowing. That's not easy to put in because I have to make different layers for that as well. And everything. So that is why making the thumbnails just half of the video. Making the video and editing it takes about an hour or so. And then doing the thumbnail takes about 45 minutes. So almost about 2 hours in total to spend time on YouTube making a video for you guys. But if you go and look up on YouTube, in order to include, and I got this, have you guys ever watched vidIQ? vidIQ on YouTube. Have you guys even watched that at all? Let me know in chat. Because everything that you see, the titling, the tags, and the titling and the thumbnail came from vidIQ, from different YouTube influencers. All right. And so they told me that if you want to get to a broader audience, you're going to have to do this, David. You're going to have to do this. You have to put good titling, eye-popping titles, clickbaity titles, and thumbnails in order to reach an audience. That's the only thing you can do. Because if you have a bland, boring looking thumbnail that doesn't show much, no one's going to watch it. No one's going to watch the video. You have to, think about a thumbnail, folks. And I even told myself this where I work at a grocery store, and I was telling myself, think of a thumbnail, David, like a box of Cheez-Its. The image in front is your thumbnail. It's up to the customer if they want to grab that box of Cheez-Its, pay for them, and go eat them, right? So think of thumbnails like a box of Cheez-Its or whatever food you like to buy at the store, chips, Pop-Tarts, whatever, gummy bears, gummy worms, chocolate, whatnot. And believe me, the store director, I don't want to give out his name for many reasons, but he's also taught me on how to do this. It's video marketing. It's in the marketing industry, and you have to strategically lay out your title. You have to structure and lay out the foundation to make these videos volatile to your audience. Because I can search up weather right now. Let's just do weather forecast. Okay, weather forecast for today. Okay, and let's just look up this. Which thumbnail? Actually, you know what? Let's do this. Which thumbnail are you going to likely click on? Okay, I'm going to number these. And this is like a little game, really quickly. A little game. This is 1. This is 2. This is 3. All right, and this is 4. So which thumbnail are you to click on? When you see this, when you see these thumbnails, which one are you likely to click on? And look at the titles too. Let me know what you guys think. All right. So 2, 4, 4, 1, 3. Okay, someone said 3. 2. Interesting. So some of you think 2 is pretty good too also. 6, there's no 6 on this in the search query that is here. All right, but notice a good chunk of you have said 1 or 4. And why is that? You know why? What gets your guys' attention? What gets your guys' attention? Red, right? Red gets your attention. Big wording gets your attention. By the way, I gotta give a huge shout out to Max Velocity. Love your thumbnails, brother. Red gets your guys' attention. Look at blues and reds get our attention too. And big words like this get your attention. So I'm gonna click on a video, these 2 videos, even my video or live stream here, before I click on anyone else's. Because when you look it up on search, you're gonna come across a lot of blandy looking thumbnails, like things that are like this. I'm not gonna click on this right here, which is my local meteorologist TV guy that I like to watch. I'm just not. These thumbnails are not eyeball attractive. They're just not attractive to me. So that is why I feel like I just talked about this like 4 or 5 months ago. You have to strategically grab the viewer's attention, okay? And people might say, that's all that YouTube is now, clickbait, that's all it is. Yeah, I'm being honest. That's clearly what it is. That's what YouTube surrounds themselves in, is clickbait. But here's the thing. I want you guys to understand, and hopefully this clears out a lot of confusion. There's good clickbait and there's bad clickbait. All right, so if I took an image like this, well, not really like this. If I made a video today, all right, and said historic or deadly historic storm, they're just 3 words going across the image, deadly historic storm. And you guys watch that video and I don't mention it once in the video, nor do I say it. That's a bad form of clickbait. Okay, that's bad. It's not good. You will get in trouble by YouTube if you use a bad form of clickbait. But then there is good clickbait. So if it's like big snowstorm coming, and then I talk about a big snowstorm coming, that should tell you guys that, oh, okay, that's not misleading. The reason why some of you say it's misleading, none of you or not all of you watch through the very end of the video. You got to watch most of the video because the details are in there. It's all in there. All right. So, wow. Just with that, people tuned out. Sorry about that if I tuned you guys all out of there. And I do have my boundaries, believe it or not. Okay, if I do go a little over the top, I'm sorry. I am very sorry. Yep, Magic Moon people do out there. And out there, I'm not saying anyone here, but yeah, there are people out there on YouTube that like to go after other people because of clickbaity titles and thumbnails. But I learned it through marketing, through government, through economics. So, yeah, I know my stuff. I do know my stuff. Alrighty, folks. Are you ready for something very, very fun? Are you guys ready for something very fun? Magic Simmer's ready. Are you guys ready for fun? All right, so imagining simulating weather, or not simulating weather, but looking at weather models, and it's a weather simulation. Good luck. Look what we found. Our weather simulator. Our weather simulator. Let me actually go to full screen. Yeah, this is our weather simulator, folks. You have your skew T diagram, and the green line, which you'll see here, is actually the parcel line. That's the parcel lapse rate. So, like when you get lots of CAPE, you get a positive area. That's when the green line is to the right of the red line. So where my arrow's pointing at, there is some instability on the sounding, but it's more elevated instability. It's more in the elevated layer because we have a capping inversion. So then I could actually mess with a lot of settings. If you guys want to check this out, there is a link. Oh, not that. Oh my gosh, come on, there we go. I need the link, there we go. So this is the link to this website. Neil, or no, wait, not Neil. Who is it? Got the guy. Oh, Zias, my friend Zias, actually codes this and makes the weather simulator. I know him. He's from the Netherlands, really good guy. And he has put a lot of work into this over the last year or so. Very good weather simulator. Probably the best, the very best out there on a website. And now it's dark, so let's make it daylight again. Make it daylight. And so you can see some fog, right? There's some fog. And I could even make an urban area. So let's draw a little urban area. So here are some buildings. We could even make a runway. So, like where planes, you can fly in this game too. So there is the tarmac, which gives off different heating. So if we actually go to our temperature map, you can see it heats up a little faster because of the asphalt. It's black, so it's going to absorb more of the heating. And you're going to get a lot of a good thermal. And then here is your little city. Look at this. Let's zoom all the way in. Look how cool that is. Yeah, simply by using this simulator, I was able to learn more about fluid dynamics, how the sun heats the land and the land heats the air above it, and the heat rises. And so this is a city. This could be Houston, actually. Houston. And yes, your buildings do repeat themselves. That's the thing I hope he can fix eventually. But you can see now, if we look at our sounding, 67 degrees at the surface. You could even do this. Watch this. You could even add, so we have urban. We could add looks like we got thunderstorms already popping up here. Yep. See? Got thunderstorms already developing, or some clouds. Those are clouds. We can put up our weather station. So let's just say I want a weather station by the airport. You can bring that up, and I could have a weather station in the urban area. So a couple of weather stations, and then here's a hill. So the hill, you can see snow falling because it's colder. Let's go back here. This is kind of like the high plains. This is another mountain that I drew up. Another little valley, another hill here. And then this is the ocean right here. So I can put a weather station there. And notice when we do this, it's 52 degrees, the water temperature. Now, the water temperature does not warm or cool with the ambient temperature. He is working on that with his next big update. He will encode that in and incorporate it into the simulator. But this is really fun. This is very addicting. And here's morning again. So I just resetted the time. Now, another cool thing you can see in the simulator is station plots. So I can see what the temperature and dew point. The dew point is the blue line down here, and then a turquoise, and then the red line is your air temperature. So as the air heats up, there's mixing going on, and you can see how the dew point drops as the temperature warms up because there's mixing going on. Cities are heat sinks. Yeah, they're heat islands, basically. So as we go throughout the day, and the time is up here, and the time of the year, there's no year because it's just the same thing repetitively. But yeah, this is going to, and sorry that resetted because I changed latitude. But you can see here, it's 9 in the morning, June 21st, so this would be the longest day of the year, and you can see the clouds. Now I could actually let's see here. Air is kind of dry enough, so I could probably make a little microburst. Watch this, you guys. Are you guys ready for this? Microburst. Boom. And look at a little shelf cloud. And as that air moves out, it actually cools off. And then you can see the snow, the rain, and everything. Yeah. No one knows about this really except me. Surprisingly, not many people have discovered this. And there's lightning. Look at that. Actual lightning, folks. And there's snow, and then the turquoise is freezing rain or sleet, or kind of a rain-snow mix. Now, I don't know. I don't think he has incorporated to where you could actually make freezing rain. Maybe he will do that hopefully soon. But yeah, you can see the temperatures have cooled off now because of all the wet weather. And the air is very saturated. Now you want to see what happens? Let's see what happens when I make the air really dry. So we're going to just get rid of all the humidity. Air is going to get really dry. Actually, you know what? I'm going to make the air much warmer. So I'm going to do this. So I'm going to increase the heating aloft. So temperatures aloft are about 56 degrees. And then the city actually lights up at night. And most importantly, you're going to like this too. Now, see, look how dry the air is now. Really dry. Really, really dry. Especially in the low levels. Look at how low the dew point is. Dew point is low. I'm telling you, it's very dry. So what we could also do here is... let's do this. Air quality. So we can see what the air quality is. So there's different selections you can do. You can look at air quality. Oh, my face is in the way here. Let me get my face out of the way. Take me off for a second. So you can see down here that we have different selections. Curl, precipitation, moisture. I don't know what these are. I will have to look into these. I really only know water vapor. This is our water vapor right here, pretty much. Okay, I better stop the surface heating because, boy, or low-level heating. Look at that inversion right now. Look how warm that is. So that gives us a temperature roughly about 86 degrees, or actually about 88 degrees. And so what I can do here is we can look at water vapor, temperatures. What is our temperature profile in the virtual? Orange colors indicate temperatures that are mild to warm. Pinker colors, colder temperatures. And then you got your inversion down here. So this gives us a pretty good idea what our weather pattern is doing. This is a very stable atmosphere, by the way. This is not very unstable. So what we're going to do is we're going to let the sun come up. It's going to come up really soon here. And look at our station data, by the way. So evidently on this one, we actually have fog. We actually have fog that has developed. And our humidity is roughly 100%. It is 100% at this point. I know that's hard to see, but that is 100% humidity because our dew point and our air temperature are both the same. So now we're going to actually lower this and watch the air temperature come up. Watch what happens. So if you're wondering why some days are hotter than others, well, you can blame the low-level temperatures for that. Because the warmer the low-level temperatures are, the quicker the warming happens. So we can see this here. So let's dry out the atmosphere. Actually, let's get rid of that right there. There we go. We got some drying, but not as much. But look at our dew point right here. It's separating because the air temperature is warming up, but there's so much dry air that it's mixing out to the dry adiabatic collapse rate. That's why your dry adiabatic collapse rate is steeper than your moist adiabatic collapse rate. Why some days the air will start off moist during the morning and then it will dry out during the day because you get that mixing. Like, well, oh yeah, look at right here. It's really mixing out now. This really is very realistic. The albedo is really good. Look at this. This is incredible. That asphalt really reflects the heating that is strongest. And look at the dew points. Very dry air. Air is really dry right now. You could make a tornado, but it's in 2-dimensional. It's not in 3-dimensional. And believe me, if you want to simulate weather in 3-dimensional, your computer will have a heart attack. It will freaking kill your computer to it would break your computer almost. Because imagining doing this in 3-dimensional, too many processes going at once. Too many processes. Let's up the sun intensity. That will help things out a lot more. That will bring up temperatures way more. So our sun intensity is pretty substantial. And look at what's going on here. Our air is actually drying out. It's 85 degrees. So you can see how this all plays out. Let's look at our curl. You can see the curl as well, the updrafts in motion. And you can see horizontal. This is vertical, so your updrafts are in red, your blue colors are downdrafts. So you can see what the atmosphere is doing as the land heats up. And wow, this is a very, very dry atmosphere. Look at how dry this is. 8% humidity. Very, very dry. Very dry. Now it's time for the fun part. Talk about a downdraft. Are you all ready to see a downdraft? Are you ready to see a downdraft? Because we are going to make one. We are going to make a downdraft. Here we go. Here comes a big downdraft. Extreme downdraft. And for that, let's lower this down. So we're going to make this run a lot slower. Big downdraft coming. Here we go. Seizure warning, by the way. Seizure warning. Seizure warning. Look at this downdraft. That is 100-mile-an-hour winds. Yeah, look at this. Look how strong that is. See if I can make it. I gotta speed it up a little bit more. Yeah, look at this. You can see the wind. Look at how strong that wind is. Boom. So that's why when the air is very dry and you get thunderstorms above that, it can get really nasty. Pretty cool, huh? Pretty stinking cool. And now look at, we have fog. We have a lot of fog. Look at how the atmosphere is behaving. Pretty crazy. So now if you don't like the atmosphere, how it's behaving, you can go to drag, increase the drag, and that will slowly get rid of any... Really cool. I'm glad you like it. I'm glad. We'll do this for a little bit more. Then I'm going to actually have to head off here in about 10 or so minutes. What do you guys want me to create next with this simulator? It's going to have to be done more naturally. Maybe I could do it artificially. What do you guys want me to do next? Which, by the way, you can check out the link there to go to the website. I did forget to tell you guys, it is very computer intensive. So if you don't have a strong enough computer, it's gonna render some really low frames. So right now I'm getting about 13 to 15 frames a second. So if you have a really bad graphics card or processing unit, you might get like 4 to 5 frames per second. Remember, these are calculations, just like our model. It's what that is. Jody, he's working on air pressure. Actually, you know what? Let me show you guys what this guy's actually currently working on. Let me get the Discord message of what he sent because let's do this. Yes, I think it's so it's from actually let me go here 2D weather simulator and go over to GitHub. And then if you go to projects like I am here, this is the latest update. You can see what he's currently working on. So he is going to be working on this stuff, or he's currently working on this now. Okay. And then he's going to be working on this dynamic water temperature, realistic sounds, rework fluid simulation with real pressure simulation, air pressure. Okay. And everything. But that's going to take a lot longer because that's more advanced to code into the simulator. So it's not like an overnight thing. This guy works quite hard on this to make this all possible. Oh, make sure you join the Discord server. Link clickable now. Yes, if you guys have not joined the Discord server, we do have a weather server. Boy, this whole time I forgot to promote this. If you all are interested, we do have a Discord server that we opened up almost a week ago. If you guys are interested, there is the link. Also easy, I highly recommend you checking this simulator out too. So you can see how much higher your dew point is. And watch what is going to happen here once the temperatures heat up enough. And this is actually really thick cloud cover. Will it actually be able to mix out? Let's see if we can get... There we go. Man, it is not mixing out. Hey, it mixed out in town, though, the cloud cover. So, let me turn this down. Oh, my goodness, it is over. Let's do that so you guys can see the city still. So, yeah, there we go. Now the clouds have burned off. Now we have that mixing going on. Now, if the conditions are ripe enough, we can get thunderstorms, but we do need to bring down the temperatures. Air is really, really, really dry, though. Let's see if we can do something here. There's a good updraft. No lightning out of that, though. Let's see if we can get more lightning. There is no lightning at all. Thought there would be lightning with this. But hey, I got rain. I made rainfall. It's raining in the simulator. Wow, look how wet it is over here. Really wet grounds. Now let's add some wind. Let's turn up the wind a lot more. What's up, the Edon Chronicles? I don't know if you're the one that spammed earlier. I recognize the name. So for now, sorry, you can't. You're trying to be a mod to ruin my YouTube channel, so I'm sorry. It's not going to work out. Not going to work out. Okay, so you're a different Eden. Because there was another Eden in the YouTube chat that was just spamming like crazy, repetitively. What a mess. What's up, George Smith? How are you? So, yeah, as far as modding goes to the YouTube channel, Albanian. Oh, okay. So the Eden, how moderator works, you'll have to be active in my YouTube live streams, and show that you do care about the channel, you care about the work that I do, and then we will look into you being a mod down the road. I don't want to give anyone mod. The reason why I gave George Smith mod because of all the spamming that was occurring earlier. So now we got wind that is taking place here. If we add more moisture, let's add more moisture to the mix. We should get some lenticular cloud formations. And you can see right here, we got lenticular cloud formation going on. So what do you guys think of this weather simulator? Let me know, please. What do you guys think about this? What's up, Jody? You just got on Discord? Nice, nice. Got some new joiners? Yes, welcome, Eagle Fan. Welcome, Jody, to the server. Hey, we just reached 30 members. Thank you. By the way, make sure you all verify, please. Please, Jody, Chris, you have not verified yet. Which, by the way, these people are going to be kicked because they have not verified in time. So they are gone. So make sure you do verify, you guys. K-John, how are you doing? What game are you playing? It's 2D Weather Sandbox. There's a link that is pinned to the chat. If you guys are interested in playing this, dude, I'm telling you, for the love of God, it is very addicting. It is addicting. You can create your own weather scenarios. Heavy snow, heavy rain, microbursts, hailstorms, orographic effects. You can create literally just about anything. Like here is a classic example of orographic or lenticular clouds. And you can look at the wind too. Look how strong the wind is. You can even get winds up to 80 miles an hour. And if that air compresses and comes down enough, there's an inversion here. So evidently that's not going to work very well. Not going to be able to mix all the way down to the surface very well. Well, when it does try to do so, air gets really dry. And so you can do a lot. This is pretty fun. This is addicting. This is the wind. Yeah, so how I see this is if it's red, it's westerly wind. If it's blue, it's easterly wind. Because, of course, in two-dimensional sense, there's only two directions, not 3 or 4. So red is west wind, I put it, because it goes from left to right, and east wind is from right to left, and that's blue. That's how I interpret it as. You can interpret red as in east wind and blue as in west wind, but I do it this way. And then, of course, you can look at your IR heating, which is a bit more to explain. And then there's your curl. So you can see what your curl looks like. You can literally see what it's doing on the leeward side of a mountain. And look how strong this wind is. 90 miles an hour. Look how very strong wind. Oh, also, you know what you can do in this game? Let's add some vegetation. Add some vegetation to the mix. I have some bad news. The city is going to be burnt down to a crisp because we're going to create a fire. There's your fire that has been created. And so you can see all the smoke going into the air. And if we go to our air quality, you can see what it looks like. And remember, smoke rises, so that's being taken into consideration. That's why your air quality actually is a little bit better at the surface than aloft. Wow, that is some strong wind up here. Look at that. That is almost 100-mile-an-hour winds. That is very strong. And look at, you don't get any rain or anything. You just get snow. And then here's another lenticular cloud. This is what you call a mountain wave event, actually. There's your fire. It's still burning. And it literally can watch it burn these buildings. What do you guys think of this? Pretty cool, huh? Very addicting. Very addicting. Yeah, it's pretty much like California wildfires. This is a California wildfire right here. Where did I find this? So a friend on Discord, recommended it to me, and he said, David, you should check out this weather simulator. I'm like, what weather simulator? I'm like, this. And so I've been following this guy that has made these weather oh gosh, big firestorm. Oh my, big firestorm in progress. Big firestorm. Look at this big firestorm. Massive firestorm in progress. So, you could actually, I followed this guy for a while since I discovered it. And I'll tell you, oh my goodness, it is addicting. The game is addicting. I mean, you could literally view different things. Relative humidity, how much water vapor is in the air. This is realistic. This is your temperature, by the way. So this is what your temperatures look like. There's your kind of like little cold front that's rolling through. You can see the temperature contrast. And yes, when you make the land more moist, like what you're seeing here, this is going to delay any significant heating. The drier the land, the faster the heating, and also the material type. So if you use a runway tarmac, you will actually be able to heat up the air more faster because the asphalt's black. Let me get the instruction book because there is you can fly in this. You can literally fly. Let me figure out how to do that. So aircraft flight simulator mode is A. So if I go to A, look at the jet plane. And it's flying through the clouds. And yes, there is landing gear. So if I hit shift, oops. Uh-oh. I don't want to drop. I don't want to drop. Let's go up. Let's go up. Come on. Ooh, big. Oh gosh, I'm stalling. No, I'm stalling. So if you hit shift, you could actually declare the landing gear. I believe, is it shift? It is shift. Yeah, I hit shift. I'm just going to have to get lower. Nosedive. Here we go. Nosedive. Why is the landing gear not being deployed? That's crazy. Is this even working? The landing gear has to be deployed. Or maybe it's this button to deploy it. There we go. There's our landing gear. So it's the other shift button. That's an Airbus. So you could actually land in this game. So I'm going to exit out of that. Pretty cool, huh? Not want to be on your plane. Oh. Oh, yeah, I know. You do not want to be on my airplane. Totally not. Yeah, looks like our fire is finally extinguished. But there's just all this smoke that's left behind. And then let's see, what other settings? This is the wind. This is your updraft. As you can tell, there is some bugs with this, minor bugs. If you start encountering it to act like this, just increase your drag. The wind will slow down gradually. As you can see here, your reds are going away. And now you have no wind. You have no wind. So let's turn off our drag. Turn down our drag, that is. And then you'll see different layers. This is your heating, IR heating and cooling. Figured out what that is, but it has to do with smoke and other things. And then this is your IR down. So how much infrared is hitting down on the planet. And then this is your IR up. How much infrared radiation is going out into the atmosphere. And precipitation mass, that's a new one that he just added. And then there is other ones. Air quality is one of those. And look at how bad the air quality is. Look how bad. Oh my gosh. Air quality is insane. Who wants to breathe this? Who wants to breathe that air quality? What's up, Frankie Maz? By the way, the weather station will actually, you will be able to see the air quality on here. So if you hit the button here, oh, the air quality was a lot worse earlier. It is 2,500 units. That's pretty bad. It's still really bad now. It's in the hazardous, but it's definitely a lot better than it was before. But then when you have all this smoke, it actually affects the air temperature over time. So you'll actually get global cooling. And see how your temperature is just going down, going down, going down. You're actually getting global cooling. That's the air quality. Yes, this is the air quality. Let me bring my face back up here. So yeah, that's the air quality. Can you simulate a nuclear winter? Of course I can. Let's simulate a nuclear winter. You know what a nuclear winter looks like? Are you guys ready for this? This is what a nuclear winter looks like. That's a nuclear winter. And, I broke the simulator. That was not fun. Which leads me to this. So if you want to create a new simulator, you can save these simulators as well. So just choose the file. I've saved many. So we'll just use this one again. Actually, you know what? You know what I'm going to do? Is I'm going to create one fresh for you guys. So, by the way, your altitude of the atmosphere, so 1,500 meters is about almost 15,000 meters is almost 50,000 feet. Now, of course, the bigger your atmosphere is, it's going to greatly impact performance. Your vertical resolution as well, I keep that at 300. This is the one that you want to change. So if you turn this down to like 500 pixels, I believe that is in pixels, we start simulation, it's going to make it run a lot faster. But also, it's not really as big of a area you can draw on. So, and see, I'm getting over 50 frames a second because I have a strong computer that can handle this. So let's do this. So we're going to increase the land evaporation. We're going to increase our sun intensity just a little bit. Bring our sun or our latitude down. So what you're going to end up seeing is the simulator is going to run a lot faster now. So you'll see this. It runs a lot faster because I have an area. This is my area that I'm drawing in. So it's not as big. Okay. It's not as big. But that will depend on your computer size. So you will want to do some adjustments. Ooh, that was cool. Did you guys see the cap cloud? That was really neat. You can see the little cap cloud as that convection was going up. So that's that. And then you could literally go extreme on this. Okay, so let's go back to that again. We can go all the way up to 16,000 pixels, which you don't want to know how big that is. My computer could barely handle this. So what we're going to do, just do it like this. See how slow it ran? It just loaded much slower in. It is not fast at all. I'm getting literally 3 frames a second. Okay, and you're probably asking, well, but why? Because look at how much bigger this whole area is. Even so it looks almost the same size, this is much bigger. In fact, the biggest possible image you can make or weather simulating, drawing, or simulation area is about 500 miles. Okay, so from one end of the image, so you'll see up here at the top, you'll see how many miles. So this is 20 miles, 40 miles, 60 miles. This is 200 miles right here. And then if you go way over here where my mouse cursor is, it's 450 miles. This is as good of settings as I have. And look at how much slower this is running. What's up, Mountain Wolf? How are you? I don't know if you guys are still watching, but It is important to take note of that. If you want the simulator to run a lot faster with good performance, you're going to need to adjust your settings. And again, you'll have to fiddle around with it for a bit in order to get used to it, okay? And to figure out what will work best for you. But this is maximum, and I'm getting literally 2 to 3 frames a second on this. That's not very fast at all. That's a very slow rendering time. But if we go back and go to it again, and actually let me, yeah. So if you even lower the atmosphere a little bit and see what that gives us. I think this gives us even, oh yeah, this is not very, this is a very thin atmosphere. This is like a Mars atmosphere, or Martian. And this gives us only 330 miles. So you just have to fiddle around with it and everything. All right, any questions, anybody? Wow, it's already 8 o'clock. This has ended up being a 2-hour stream. You guys asked me to make a 2-hour stream, so that's what we did. That's what we did. So what did you guys think of it? The live stream tonight. What did you guys think of the weather simulator? I would highly recommend checking it out. Link is pinned to this live stream. That's what I wanted to show you all. Thought, man, you guys are going to love this. Perfect night to do it. But again, yes, George Smith, I am in California, bud. Thank you for asking. By the way, if you guys did not subscribe yet, please do so. Ta-da! Thanks. Use it in your forecasts. No, it's a simulator. It's a game. It's a weather game simulator. It's not actually, I cannot use this in my forecast because it's a simulator. Yeah, very fun, very fun. Also, you can create a very humid atmosphere. I wanted to show you that really quickly. Oops, no. Actually, yeah, we'll just use this and draw. Yeah, there we go. So this is all water here at 25 Celsius. So this is a very humid atmosphere. And if we actually increase the temperature a little bit, what all happens? Gets really warm. And that's what a humid atmosphere looks like. Let me see if I can create a tornado. You guys wanted me to do that? A little bit of tornado there briefly. I can recreate the Martian atmosphere with a lower resolution. Actually, you know what I can do is cool off the atmosphere a whole lot. Let's do that. Let's have some fun with this really quickly. And then, yeah, look at our atmosphere cooling. Oh, my simulator is going to love this. Look what I created. Oh my gosh. So yeah, I'm already addicted. Oh, that's fine, buddy. It's fine. I understand. But yeah, that is basically the atmosphere at work. All right, I think that will end it there. Any questions, anybody, before I head off? Looks like weather on Jupiter, I agree. All right. See you on Discord, Jody, by the way. I see that you joined, so thank you for joining the server. And okay, you verified. Sweet. Sweet, sweet, sweet. You're in, you're in, you're in. I'm gonna do these once a week at least, I think. As far as it looks, probably Saturday. Saturdays, because it's a weekend, people are home. That's the plan. I can't guarantee every Saturday, but at least once a week, I will try. You're very welcome, Magic. I love you guys. I do. Love my audience. I love my audience. I just got to figure out what my audience really likes a lot and what they don't like to watch. It's hard to figure that out, but I'll try my best. Really welcome, Wendy. Winding Road. Yeah. All right. I think I'm going to head off. Boy, my stomach is growling. My stomach is growling. Saying it's hungry, so I do need to head off. But thank you all for tuning in. Have a great rest of your night, and I'll see you back here tomorrow. Tomorrow morning. Set your guys' alarms for 2 in the morning. We're going to have another video out, and that will be the only video of the day. I'm not doing 2 videos because tomorrow I am going to be busy after church, so therefore I will have a morning video out tomorrow and an afternoon video out on Monday. So it's going to be kind of really back and forth. It just depends on my work schedule and everything. But make sure you have those notifications on if you haven't already, okay? Because I will be out. I'll be uploading tonight at around 2 in the morning. That will be 5 in the morning Eastern time, 5 in the morning Eastern, 2 in the morning Pacific time. All right, yes, 2 a.m., George. That would be 5 a.m. Eastern time, 5 a.m., all right? As always, have a great rest of your night. I'll be back with you more tomorrow morning. Cheers!